Okay, in this video we are going to take a look at how to solve systems of equations using a couple of different methods. We'll look at two methods of using substitution, and then we will also look at elimination. Both of these methods are viable for every problem, but depending on the problem, you will find that one of the methods may appear to be easier to use than its counterpart. So let's get into it. All right, on number 11, or the first problem on the makeup test, we are given x plus 3y equals 1, and negative 3x minus 3y equals negative 15. So I'm going to transfer that to my writing surface. This is number 11. X plus 3y equals 1, and negative 3x minus 3y equals negative 15. Okay. So, let's take a look at this for a minute. We have talked about substitution quite a bit, where we would solve each of these equations for y equals, and then we would drop the y and then set those slope-intercept equations of a line equal to each other. So that would be useful if our goal was to be able to graph those equations. All right? But if we were only interested in quickly finding the x and the y values and moving on with our lives, which I think all of you are, right? Just want to get it and move on. There is a quicker way. Would you like to see the trick? Interested? All right. Does everybody have a straight edge or something to draw a big line? You can share that one. What we're going to do is draw a big line underneath both of the equations. All right? And we're going to put a plus sign right here. Now, what would happen here if I were to add these equations together like they are? What is x plus negative 3x?
Negative 3x squared?
I'm just adding.
No, wait, no.
Just negative 3x?
Negative 3x plus x. Yes, there's a 1.
Also, what it, negative
2.
No, because it's a
Yeah.
negative 3.
Negative 2x.
X.
Okay. So this would be negative 2x. How about 3y minus 3y?
0.
0. So,
Put y.
wait a minute. I just eliminated the y, didn't I?
Yeah.
Because plus 3y minus 3y, combine those two things together, you know, it's like a black hole. It disappears. Okay? So you can cross these out. And what you just did was you eliminated the y variable by adding. So now we'll just continue. Equals, what's 1 plus negative 15?
Negative 14.
Correct.
What they said.
Now guys, look how quick this is. So now what do? I've got negative 2x equals negative 14.
Divide.
Divide both by negative 2, right?
Yeah.
Okay, so these negative 2's cancel, and I have x equals negative 14 divided by negative 2. So what does x equal?
7.
7.
Yeah,
Was that fast, or what?
it was very fast.
Okay, so now we plug this 7 back up here. You see where this says x plus 3y equals 1? So I'm going to write blank plus 3y equals 1. And I'll stick that 7 in there for where the x was. Okay? So now I have 7 plus 3y equals 1. What do I do?
7 minus 7.
Uh-huh.
And then you would do 1 minus 7.
Right. So these cancel, leaving 3y equals 1 minus 7, negative 6. Now what?
Did you do that?
Yeah. Divide both sides by, why negative 3?
Oh, I was right.
Just 3. Divide both sides by 3. These cancel. And so y equals negative 6 divided by 3. What's that? Negative 2. So what are my x and y coordinates of intersection for this system of equations?
X equals 7, y equals negative 2.
Yes. So open parentheses, 7, comma, negative 2. Was that easier?
Yeah.
It was.
Yeah. It's like this. When you're learning a martial art, you know, there might be some quick way to quickly subdue your opponent, but you have to spend whatever 10 years just
To learn that.
learning until they give you the secret method. Well, it's kind of like if we just show you this method, then you would never want to learn substitution. But there are times when substitution is actually easier. So that's number 11. That was easy. Let's move on to number 12. Now, what I'm telling you here is that if I told you you had to solve this using substitution, then that would not be a valid way to solve it, because that was called elimination. That's what we just did, and we haven't studied elimination yet. But it's the thing that comes after substitution in the book, so that's what we were going to get to after the break. But y'all just learned it. That was how easy it was, by the way. Okay, so now we're doing number 12. Negative 3x, so now we're doing number 12. Number 12, negative 3x minus 8y equals 20. Negative 5x plus y equals 19. So that's our system. That's our system right there. Okay. What might we do to solve this system?
We're not doing elimination, are we?
Maybe we should. Because maybe that would be the easier way. Now let me explain about elimination. Let's.
It always works though, right?
It always works, but it sometimes it's really complicated. So here's the deal. Let's take a look at this. We have a negative 8y, and then down here I've got y all by itself. What could I multiply the whole equation by to make this y positive 8y? What could I multiply the whole equation by? 8. Good job. So go over here, put little parentheses around your lower equation, and write an 8. Now here's how elimination works. So what you're doing is you're thinking in your head, I want this y to be 8y. That way when I add negative 8y plus 8y, the two y's cancel out, and I've eliminated the y variable. So now here's how you do that. So last time up here we didn't have to do any of this. It was already set up for us. But down here they're saying, well, you got to do this one step. And when we multiply the whole equation by 8, yes.
Okay, so back to the other one.
Yeah.
Why didn't we do the x like we're doing now? Or like when it just has the x plus negative 3x. Why didn't we just do the same thing we're doing right now with the 8?
Oh, well, we didn't need to because this was already 3y minus 3y.
Is it because, like, I'm talking about the x though, because, like, would it just be 1? Is it because we just have a 1 right there automatically by the x?
Well, we're not worried about the x right now. We could have done this in an alternative way. We could have multiplied the entire top equation by 3, and then we could have eliminated the x. But we chose to eliminate the y.
No, you don't understand. I'm asking why we didn't do the x like we're doing the y right now. Like, you know, when it's by itself? Or am I confusing you anymore? That's all I'm confusing.
We only, okay, I think I know what you're asking. We only eliminate one variable per problem. We don't eliminate both of them. So we chose to eliminate the y's, and we solved for x. We wouldn't want to eliminate both the y and the x, because then we wouldn't have anything to solve for.
Oh, okay. Now
All
I
right.
get it.
So now down here, we're going to distribute multiply this 8 through the entire equation, even to the 19 over there. So we might need to do some little computational work here. 8 times negative 5x. Negative 40x. Plus 8y.
Plus 8y.
Yeah. Equals 8 times 19. 152. Alrighty. Now that we have written this out like this, take this equation up on top that we didn't do anything to, bring him down here, write him in there. So write exactly as it appears, negative 3x minus 8y equals 20. Now take your straight edge, draw you a big line and a plus symbol, and this is called stack adding. We're stack adding. So we always line up our terms beneath one another. So we're going to add negative 40x plus negative 3x.
Negative 37?
Well, I have negative 40 and negative 3. So when I add those two things together,
It's a
Sorry.
positive number.
no, when I add negative 40 to negative 3, don't I just get a bigger negative number?
Negative 43.
Negative 43. Negative 43x. 8y minus 8y cancels. Yeah. Equals 152 plus 20 is 172. Right?
Yeah.
Okay. So now we divide both the left and the right by negative 43. So check that out in your calculator. So 172 divided by negative 43 equals negative 4. So x equals negative 4. Anybody think that that was easier than all that we've been doing? It's still easier. It's faster. And it makes a little bit more sense. Okay, so now we have this negative 4 for x. So I can go plug this into either of our original equations. Got to be the original equations. So I'll go back here, I'll plug it into this top one. Negative 3, open parentheses, close parentheses, minus 8y equals 20. And then I'll plug in there negative 4. So I have negative 3 times negative 4 gives me positive 12 minus 8y equals 20. What do I do now? I want to get y by itself. Subtract 12 from both sides.
Wait, wouldn't you add those to subtraction?
Add what?
12 because that's the subtraction sign. Wouldn't it be plus?
Where is the subtraction sign? This is positive 12. Oh yeah, this is negative 3 times negative 4. It should just be positive 12.
Yeah, but look at the sign. 12 minus 8y, that would be plus because you're doing the opposite.
Oh, cover this up. I just want to get rid of the positive 12. So if I just want to get rid of 12, I subtract 12.
That's what I understand. You just subtract 12.
You just subtract 12 so you can get y by itself.
I want to get y by itself, so I'm going to subtract 12 from both sides. Okay, 12 minus 12 cancels. So I have negative 8y equals 20 minus 12. What's that?
8.
So what's y? Divide both sides by negative 8.
Would be 0.
Yeah.
The negative 8's cancel.
Because
And y equals 8 divided by negative 8, which is negative 1. So my solution, Hilmer,
Yes, sir.
so, good sir,
Yeah.
what is the equation, or pardon me, what are the coordinates of intersection for this system of equations?
Oh, you mean like x and y?
I do.
Oh, okay. X equals negative 4 and y equals negative 1.
Very,
Word.
very good. So this is the intersection point. Okay, it's also the solution to the system.
Can I just throw this away?
Sure. Okay, so now we've done 2 of them, and I think let me see, is there one more that you want me to show on the video?
Let's see.
Or do you think you feel like you understand it?
Yeah,
We should probably do one where we don't use elimination. We should probably use substitution, right? Since this,
Sure.
let's find one that would look really scary to do elimination. Okay, number 13, we don't want to use elimination, so let's see.
18.
Let's look down here at, yes, 18. 18 looks, yeah, that would be a good one. That would be a really good one. So let's look at number 18, and we won't use elimination on this one. So we're going to write this down. Good call. So here you go. Number 18. Negative 2x plus 6y equals 6. And then negative 7x plus 8y equals negative 5. So there's our system of equations. And we just talked briefly and said that elimination looks kind of frightening. All right? So maybe we don't want to solve using elimination. For this one, it wouldn't be too hard to get this in y-intercept or slope-intercept form where it's just y equals. So if we're going to do it the old school substitution way, we can label this equation A and this equation B, right? And then we'll take equation A first over here. And I'll write down negative 2x plus 6y equals 6. Now I want this in y equals form. So what would I do? Right now, negative 2x is added to 6y. I want y by itself. I would add 2x to both sides. Very good. This would cancel on the left, leaving 6y equals 2x plus 6. Remember, I'm always going to put the x up front. So now we divide both sides by 6 to get rid of that coefficient in front of the y. Those 6's cancel in front of the y, leaving y equals, now be careful here, we've got to remember to split up this denominator to go with both of the terms up in the numerator. So now I've got 2/6 x plus 6/6. Can I reduce this expression?
6.
6.
2/6 could be 1/3.
Good job. So 2/6 can be 1/3 x plus 6 divided by 6 is just 1. Okay? Now we actually have two paths we can go down now. Do you see how we have y equals something? I could take 1/3 x plus 1 and I could go stick it in this b equation here. Okay, because I said y equals 1/3 x plus 1. I could go over here into b and I could write negative 7x plus 8, open parentheses, 1/3 x plus 1, close parentheses, equals negative 5. Or path B. I solve the b equation for y, and then I set both of those y equal to each other, which is the way we've been doing it. That's not elimination, that's substitution. But which way would you like me to travel? What road do you?
Wouldn't it be easier just to do a parentheses, like putting that in the y?
Yeah, now with both elimination and the way we're about to do it, the substitution method we're about to use, the benefit is that it's going to be faster.
That's what I want, faster.
Right. The detriment, or the bad thing, the thing that we lose, is that we'll never get b in y equals form, so we can't graph the two lines.
So we don't get the coordinates.
No, we'll get the coordinates. That won't be a problem. But we won't get the y-intercepts and the slopes of both lines. Like we have here, we have the slope and the y-intercept of this, of A, but we're not going to get it for B because of the way we're going to do it. And that's one of the drawbacks to doing this, but it is faster. So I'll just make a little divider line on my paper here. And what I'm going to do is I'm going to kind of copy and paste. Or cut and paste. I'm going to clip this out of here. And everywhere I see a y in my second equation, I'm going to put that whole thing. All right, so let me show this second equation. This is going to be brought over here. I'm bringing this b equation over here. And I'm writing negative 7x plus 8. Now I don't write y. Instead, put an open parentheses. Now you're going to move this you're going to move this 1/3 x plus 1, and you're going to substitute it in for where the y was there. Okay? So we're going to put up here 1/3 x plus 1. Close parentheses. Okay? Equals -5. So equals -5. All right. Well, now what we're going to do is we're going to write negative 7x plus, and then we're going to stop, because we have to multiply that 8 through that parenthetical expression. So what is 8 times 1/3?
2.6.
Okay, that would be 2 2/3. But what I could do, intelligent person with a purple sweater, whose name I will not use.
24, right?
Think about it this way. Let me just zoom in on this a little bit.
Oh, wait.
8 over 1
Oh,
times 1 over 3
8 over 3.
equals 8 over 3. Now that is 2 2/3,
Oh,
Well,
right.
2. Okay.
right?
I just put math into this.
Yeah. So what we'll do is we'll write 8/3 x. Okay, because the x comes along for the ride. Plus 8 equals -5. Now, why don't we get rid of the 8? Put him over here. So we have the x factors all by themselves. So we'll subtract out an 8 on the left and the right. And that will cancel the 8 on the left. Now I'll rewrite what I have. I have negative 7x plus 8 over 3 x equals -5 minus 8. What's -5 minus 8?
-13.
-13. Okay, we're almost done. So now I need to get this -7, because this is really -7 over 1. And I need that to be a common denominator with this other x coefficient, which is 8/3. So I need there to be a 3 in the denominator. So what I'm going to do is I'm going to multiply that -7 by 3 over 3. Okay. So what is 3 times -7?
Wait, what?
Negative 21.
Negative 21 over 3x plus 8 over 3x equals negative 13. We are so super close. So now we can add these coefficients now have common denominators. So what's negative 21 plus 8?
Negative 4. Oh, wait, no. Negative 13.
Negative 13 over 3x equals negative 13. So now I want to get rid of the negative 13 thirds. I want to be x by itself. So how do I get rid of a fraction?
You times it.
Multiply that fraction by the reciprocal. So I'll multiply by negative 3/13. And I will multiply the other side by negative 3/13. Okay? These cancel out. Everything on the left cancels out except the x. So we have x equals now, before you start doing anything, check this out. Remember, negative 13 is really negative 13 over 1. So these 13s cancel out as well. The negatives also cancel out, okay, which leaves just 3 over 1, or x equals 3. Okay, so let's finish this off. We have this equation right here, which was the the slope-intercept form of A. This is A. So now we can plug this 3, since it says x equals 3, we can plug this 3 value right in here for x, and we can solve for y. So I can write y equals 1/3 times 3 plus 1. Okay, so y equals 1/3 times 3 over 1 is 3 over 3 plus 1. So y equals 3 divided by 3 is 1, 1 plus 1. So what does y equal?
2.
So last but not least, what is the point of intersection for this system of equations?
Y equals 2, x equals 3.
So 3, 2. And that is the solution to this system of equations, 3, 2. It's also the place where these two lines would intersect if you were to graph them. And that will conclude the video. I appreciate you watching. Hope you found it useful. If you did find it useful, please make sure to like and subscribe. Thank you.